Welcome to homework.
We're going to consider a set of four black holes here, writing down their masses as 10 to the 12th, 2 times 10 to the 31st, 2 times 10 to the 35, and 2 times 10 to the 39 kilograms, where I have taken the liberty of already converting from solar masses to kilograms for the last three black holes. The conversion for that being 2 times 10 to the 30 kilograms in one solar mass. Taking the formula that the Schwarzschild radius of a black hole is simply 2gm divided by c squared, we can compute the Schwarzschild radius for each of these masses. In fact, we can make it nice and easy for us. We can throw in 10 to the 12 kilograms into this equation and get a radius of 1.5 times 10 to the minus 15 meters. And then we can note that the Schwarzschild radius is directly proportional to the mass, so all that we need is the proportional relationships between these three black holes and the first one. So when we go to our next black hole, we double the radius and increase it by a factor of 10 to the 19, getting 3 times 10 to the 4 meters, followed by 3 times 10 to the 8 meters, and 3 times 10 to the 12 meters. Okay, that's not terribly unexpected. As the mass of the black hole increases, its Schwarzschild radius will increase. What's the average density of each of these black holes going to be? If we imagined that the mass of the black hole, incorrectly, by the way, but if we took a moment to imagine that the mass of the black hole was spread evenly throughout the volume carved out by its Schwarzschild radius, well, then the density of the black hole would be equal to the total mass divided by 4/3 pi Schwarzschild radius cubed. Well, we have the mass for each black hole and we have the Schwarzschild radius for each black hole. So once again, we are going to simply plug in each of those values and we get a little bit of a surprising result. We see, I'm going to leave units for the end here. 7.1 times 10 to the 55 for our first and smallest black hole, then 1.8 times 10 to the 17, clean that up, 1.8 times 10 to the 9, and then a mere 18. All of these with units of kilograms per meter cubed. So surprisingly, if the density of the black hole were distributed in this way, it would be the smallest black hole with the greatest density and the largest black hole with the smallest density, which does indeed tell us something about how gravity is going to behave around black holes of different size.